We're now ready to dive into our introduction to content. Today we'll be reviewing psychology and the role of research in the field of psychology. There are 5 goals for this introductory lecture. First, the goal is to understand the role of research in the field of psychology and its broad applications. We will begin to review how psychology uses research to test theories and hypotheses. Over the course of this semester, we will learn how research findings get applied. Second, we will detail the scientific method as it applies to the field of psychology. This method is similarly applied in other behavioral and social science fields. Third, understand the conditions under which cause can be inferred and possibly determined through research. You've likely heard in your psychology and statistics classes that cause and effect cannot always be deduced. Therefore, we will begin to review the necessary conditions to allow for such an inference. Fourth, we will detail and review basic research. Fifth, we will detail and review applied research. In so doing, we will begin to contrast basic and applied research methods. Before we get too far into the research methods, let's remind ourselves about the field of psychology in general. Psychology is the scientific study of behavior and mental processes. Our focus this semester will be on the scientific study component of this definition. Psychology has a few key goals. The ultimate goal is to influence behavior or mental processes. You will see this discussed a lot in areas such as clinical or abnormal psychology, where the goal is to decrease psychological distress and increase psychological health and functioning. This is an applied area of psychology. Before we are able to influence, we must start by describing behavior and mental processes. Therefore, our first goal in psych is description. Let us assume that I'm interested in understanding how to influence stress so that it can be reduced. Before I can do any work to reduce stress, I must first fully figure out what stress is. To fully describe the stress would include coming up with an operational definition. Take a moment and ask yourself how you would describe to someone what stress means. How we would describe stress is part of basic research. So basic research can be conducted with our first goal in mind. That is, before I can do any experiments to reduce stress, some research might be needed to fully understand what we mean when we say the word stress. This is also a foundation to another concept called the operational definition. An operational definition details exactly how a variable such as stress will be defined and measured for the purposes of a study. This is important for our course. The second goal of psychology is explanation. Once we have fully described the variable, we wish to explain why it occurs. Where our first goal might ask the question, what is it? Our second goal asks the question, why is it? The third goal is prediction. This goal essentially asks, when or for whom is it? If I ultimately want to reduce stress, I will need to know first what it is, second, why it is, and third, for whom or when it is. When I know for whom and when it occurs, I can predict when it may be experienced in the future, and I can start to predict how I might be able to reduce it. That is, if I know who experiences it and why, I can attempt to manipulate or reduce the cause of the stress itself, so that the cause and the resulting stress are both less prevalent together. This brings us to our final and ultimate goal of influence. In the absence of a clear description, explanation, and ability to predict for whom and when things will occur, we may not be able to change the cause and thus would be unable to influence the outcome. Therefore, going through the goals in order is pretty important to the field. Finally, you will sometimes see determining cause as its own separate goal. Therefore, I'll refer to it as though we have 5 distinct goals that interact with each other. These goals will be description, explanation, prediction, determining cause, and finally, influencing. There are several reasons research is necessary, not just to the field of psychology, but to several other fields. The key reason we might use research is to help us circumvent our own biases and to gain a more objective understanding. The human mind tends to look for patterns. You might have learned about this if you took biological psychology. This both helps and hinders our understanding of our world. When we recognize patterns, it reduces the cognitive load, or cognitive effort, and allows us to experience our worlds as somewhat predictable. This can be beneficial. However, this can also lead us to develop biased or erroneous conclusions. When this occurs, our tendency is hindering our ability to fully understand our worlds. Research allows us to step outside and see if the patterns we believe we are seeing are indeed patterns that exist. Research can also allow us to test the limits of when those patterns hold versus when they cease to hold. Research also allows us to step away from generalizing anecdotes and testimonials. To generalize is to make more general or broad. Generalizing is a key term in psychology, and in particular in research method psychology. An anecdote refers to a single story or case. If we generalize from an anecdote, we may apply to many others what is only true in one instance. For example, you might hear from a student that teacher H is a terrible teacher. If you were to generalize, you would assume that all students believe that teacher H is terrible, and you may decide not to take a class with this teacher. But what if this is the only student who feels this way, and we've generalized their belief, and we now think that it holds true of all students? It might be the case that all other students think that H is a very good teacher and they've learned a lot. If you were to act on that anecdote, you may avoid taking a class that would have benefited you. Therefore, in the behavioral sciences, we often emphasize using research to assess whether a single case is common and can be generalized, or if it is rare and thus should not be generalized. Research allows us to challenge what is sometimes referred to as common knowledge. As the name implies, common knowledge refers to things that many people believe are true. However, just because something is believed by many does not make it accurate. I'm sure many of you can think of times you've been on social media or you've seen a piece of false information elsewhere that has circulated, wherein many people began to believe that it was true when it was not. Let's take an example to look at how common knowledge and false truths can be circulated. We must examine how false truths can become accepted and firmly held beliefs by individuals. I want to review a somewhat recent example of a meme that circulated around the Powerball lottery drawing. The Powerball jackpot was over $1.25 billion, and a meme started circulating that said that if you were to divide that by the number of people in the United States, each individual would receive over $4 million. This idea was that poverty could be eliminated through redistributing this lottery jackpot, which is a very nice idea. Many people saw this, were amazed by it, and shared it. Many people did not question the information, believed it, and passed the information along. This meme and related memes got over 1 million shares or likes on social media in a short amount of time. Unfortunately, the math is wrong. If you sit back and actually do the math, $4.25 billion divided by the population of approximately 300 million equals about $4.33 a person, which is not nothing, but it's not $4.3 million a person. Even without doing the math, we can step back and think about this meme logically. The payout value of the lottery is based on how many tickets have been sold and how much money has been spent on tickets. Less than the total ticket purchase price goes into the ultimate jackpot. But just to make the math simpler, let's pretend that all sales go directly into the jackpot. This would mean that the average person in the U.S. would have had to spend over $4 million on tickets. Otherwise, we wouldn't end up with an average payout of over $4 million per person. Therefore, if we reverse this statement on the meme, we would come to the conclusion that the average person in the U.S. spent over $4 million on lottery tickets. When you think about it this way, it becomes clear that the meme has an error and is not representing a fact. It's highly unlikely that anyone spent over $4 million on tickets for the jackpot, let alone that everyone did. Simply thinking logically about the content of the meme before sharing it could have prevented misinformation from circulating and becoming inaccurate, though common knowledge. This is just one example of how common knowledge can lead us to erroneous beliefs. Well-constructed research can also help us to avoid illusory correlation and to focus on disconfirming evidence. Illusory correlations are when two things appear to be related, but in fact they are not. You can think of this as the same as false correlation. We must also be vigilant to look for disconfirming evidence. Disconfirming evidence is anything that challenges what we believe to be true. As we learn more about methods of research, we'll also learn how to look for disconfirming evidence and to notice weaknesses in what we believe to be true, such as in the case of illusory correlations. Finally, research may be better able to provide us with information than simply relying on authority. If I rely on an authority to tell me what is true, I may be misled any time that authority is incorrect, whether they mean to be or not. However, if I have the ability to understand research and statistical evidence, I can identify when the authority is incorrect. I can also better identify when I am incorrect, when I am overgeneralizing, or when I am relying on common knowledge, not attending to relevant, disconfirming evidence, or I'm doing multiple of these things at the same time. Taken together, we should see clearly that scientific research is a necessary part of understanding and discovering truths in human behavior and mental processes. Engaging in research and understanding methods of research can change the way we think. Research can help us critique and be critically engaged. This doesn't mean the same as being combative or rejecting all ideas. It is to bring a critical eye and to question our own assumptions and to question assumptions that exist in other people's statements. While reading research, this means that we'd be asking things such as, how were the data collected? Are the data appropriate to answer the research question? Do the data lead to the conclusion as stated? And would I draw the same conclusion if I had conducted this research? We will also be empirical in this class, just as you were in your statistics class. In empiricism, knowledge is based on observations or evidence. For us, that means we'll focus on data. If I believe something to be true, that means I'm asking, do I have the data to support this belief? And to what extent did the data support this belief? One thing you'll notice if you have not already is that researchers tend to be tentative. What this means is that we sometimes hedge or build boundaries when we make statements. For instance, a researcher might say that two things are related, but be very tentative about the nature of causality. So a researcher might find that the amount of times people spend sleeping is related to how well they do in class, but they may be unwilling to state overtly that one of those things was the cause of the other. The researcher is likely to also take care to point out other factors that might be relevant to consider for future research, such as whether this relationship is true for people of all ages, of all genders, for those who do and do not work, so on and so forth. The tentative nature of research is also why you may notice your professors, theorists, or researchers in psychology saying things like, here's what we know, here are the limits of it, and here are some interesting questions that might need to be answered next. For instance, a researcher may say that because they sampled only college students, they are unable to determine whether the correlation between sleep and classroom performance is true for teens or children. The researcher might say that the findings might apply to teens, but that research is needed to directly assess this. Here, the researcher would be stating that there is a limit to generalizability. We'll review generalizability in more detail at various points during the semester, so keep your eyes and ears open for that word. Finally, researchers are also skeptical. This does not mean that researchers are closed-minded or outright reject things. To be skeptical means to be critical. What is the source of the information? What biases might be in the source of the information? What is the veracity behind this information? To be skeptical, then, is always to be questioning. Where is the data to support this idea or belief? Where is the information coming from? And was it gathered through appropriate means? Through this semester, we'll be learning about the methods of research that are used to answer these kinds of questions and to gather the data required in empiricism. Research is not only conducted to test our own assumptions, but also to solve practical problems. I already alluded to this earlier when I started to talk about applied research. Some research is done in response to practical problems or needs that are brought to the attention of those who conduct research. For example, if a group of patients are found not to respond well to existing treatments, it necessitates the exploration and assessment of new strategies to treat those patients. It can also help to identify how widespread an issue is, whether it has gotten worse, and whether it has improved. So research is often spawned by need. This brings us to the scientific method, a topic that you've probably learned about in other classes, but we're going to dive in with some more detail. Beliefs are not necessarily bad. What matters is whether we're willing to test them. In fact, when we look at the scientific method, opinions and assumptions are often the starting point which shape our theories and our initial hypotheses. But this is not where the scientist ends her or his work. The scientific method demands that we are willing to put our opinions and assumptions quite literally to the test. Let's view our flowchart step by step. The first step is to observe and theorize. Notice these are bidirectional. That means as we observe behaviors and experiences, we theorize about what might be happening. We notice patterns and we think about how they might relate. What we notice and hypothesize will be informed by our existing formal theories and our informal beliefs. The co-occurrence of my observations and theory should lead me to formulate a hypothesis. By definition, a hypothesis is an expected answer to a testable question. Once I form a hypothesis, I need to develop a study to test that hypothesis. A study design is all of the steps we will take or the methods we will use to collect the data. The study design should always follow the hypothesis because until you know what you want to test, you can't decide how to properly develop a test to study it. Once we design a study to test our hypothesis, we can then move towards the phase of data collection. So essentially, we observe and theorize, and from that, generate a hypothesis, what we believe to be true that is testable. We then come up with our method. That's the design for how we will collect our data to allow us to test whether our hypothesis is true. We then collect our data. We are now able to move on to the analyzing phase. Analysis is the focus of statistics classes. For instance, if you took my Statistics 101 class, there were many assignments where I gave fake data and we analyzed it to test a hypothesis. Though those data were not real, and thus we couldn't truly support or refute the hypothesis, we were able to move through the steps to know what we would do if we had real data. This semester, we will have real data. Back to the steps of the method. Once you've collected your data and analyzed your data, one of two things are likely to occur. Either you're going to support your hypothesis, or your data and results are going to refute your hypothesis. The researcher is generally hoping that the data will support their hypothesis. In the event the data and results do support the original hypothesis, we still have to go back potentially and do a new study to assess the conditions under which our hypothesis holds true. That means we have to replicate or repeat the study to find the boundaries of generalization. We also oftentimes replicate or repeat the study to ensure that our findings weren't just a one-time fluke. As you may recall from taking statistics classes, oftentimes we set a 5% chance of having an erroneous conclusion. Therefore, we repeat our studies to reduce the overall risk that the studies together have an erroneous conclusion. If two studies are done with good method and good analytical rigor, and we draw the same conclusion in support of the hypothesis, this means the evidence in support of the hypothesis is getting stronger. That is, we often will replicate to ensure that the time our results supported our hypothesis was not simply due to random chance. If I conduct the same investigation twice, and both times my hypothesis holds true, this means I'm building strong evidence for my underlying hypothesis and theory. However, our data don't always support our hypothesis. In fact, we have to design our study to allow the data to refute our hypothesis if indeed our hypothesis is incorrect. When your data fail to support your hypothesis, you go back to the drawing board. That is, we go back to our original hypothesis and underlying theory, and we make some modifications. Once the hypothesis or underlying theory have been modified, we go about designing a new study, collecting new data, and then testing the newly written hypotheses and underlying theory. Therefore, researchers learn very quickly that they need to be humble. Being incorrect is not really a problem for a scientist. If our hypothesis is not supported, we still go back and look for what we might have missed. What we're trying to uncover is the truth, That's more important to the researcher than that he or she has never made a mistake in their hypothesis. Indeed, we expect to make some missteps, otherwise we wouldn't even be engaging in data collection to begin with. Therefore, we use the scientific method to test the hypotheses that have been generated from our observations and theories. We then modify those observations and theories based on results and then begin to retest. We repeat the cycle over and over again so we can get closer and closer to understanding the truth of the world. It's important that we keep in mind that if your current hypothesis is supported, it means only a portion of the underlying theory has been supported. This is because hypotheses are narrow and drawn from the theory. Therefore, when they're supported, only that component of the theory has been supported. Additional hypotheses will be needed to assess the remaining portions of the overarching theory. In addition, each time we use inferential statistics, we take a small risk of what's called a type 1 error. This is what I mentioned a moment ago when I brought up the 5% chance of being wrong. A type 1 error is when our data support the hypothesis, but they only do so due to random chance, and they are not an accurate depiction of what is generally true of a population. Therefore, we're obligated to replicate our study to see if the results hold a second time. Either we need to replicate or someone else in the field needs to replicate. Either of these are acceptable. If a hypothesis is supported a second time, it further strengthens that hypothesis or the underlying theory. This is part of the reason you may notice many studies are done assessing what seems to be essentially the exact same question. Sometimes during replication, we actually focus on generalizability. There we might test our hypothesis using new groups or subsamples drawn from diverse populations to see to whom our findings may further apply. The final section of a research paper is called the discussion. This is where we review the results of the current study and indicate or conclude what we believe they mean in light of previous research. This is also the section of the paper where we'll detail any limitations of the current study and outline future directions. That means we're going to detail what researchers should do next and what methods they should use to overcome the limitations of the current study. We then disseminate or share the results by publishing papers, giving conference presentations, teaching classes, and writing books. Let's review the scientific approach with a little bit more depth. The scientific approach warrants data. This requires us to oftentimes actively seek out data and other information to support or refute our hypotheses and their underlying theories. Good science and good hypotheses are those that allow for both support or refutation. If your hypothesis does not allow itself to be tested, it is not accurately described as a useful hypothesis. A good hypothesis must be testable. This also means that your hypothesis must be falsifiable. This is one of the benefits of the adversarial nature of research. Once we put out a theory and/or a hypothesis, we and our colleagues may test and retest to find the limits of where it does and does not appear to be accurate. Two additional and important aspects of the scientific approach are aggregation and peer review. Aggregation refers to the fact that many of us are conducting similar studies to test the same or similar hypotheses. No single study is meant to be the end-all be-all. It's all the work together, multiple studies that generate the knowledge of the field. Therefore, if one study finds something to be true, even if it's our own study, it doesn't mean the end of assessing that hypothesis or theory. Researchers may go back and conduct additional studies. It's also necessary to seek and read studies conducted by others. Each study has specific benefits and limitations. Together, all of these studies with their individual benefits help overcome some of the limitations of the other studies. We therefore look across studies before drawing firm conclusions. From this, the field develops its rigorous knowledge. An additional step is called peer review. Our work is subject to the process of peer review. If we publish a study in the field of psychology, what typically occurs is that the scientific method has been followed and the study has been written up using a specific format that I will be teaching you this semester. The study will be then set out to others in the field with knowledge. The authors receive critical feedback about the study, its design, and their interpretation of the results. Sometimes this feedback states that the study was not done well enough for the field and should be scrapped and started over entirely. This would be when there's a fatal flaw in the design or a major limitation of the study that causes the results to be below our standards. A study may be rejected for publication if the conclusions do not match the data. Therefore, before research is made available to the general public of psychologists and researchers, it is typically gone through the review process that is called peer review. This involves other persons in the field. You will notice in your psychology classes that we want to use what we call peer-reviewed articles only. This refers to this whole review process I have just described, wherein an individual conducts the research following appropriate methods, writes it up using a specific format. It is then sent to an editor who sends it out to other experts in the field who critically review it and request feedback. If there are fatal flaws, the study may be outright rejected. If there are minor, fixable flaws, or there are potentially no flaws, but there's a lack of necessary information for that to be deduced, then the author of the study, the researcher, will be asked to revise and resubmit that study. Then the study will get published. Another possibility is that the research goes out for peer review and it comes back with no requests for revision or further information. This is pretty rare because researchers are trained to be very critical. So we typically send it back for some double checking. There's a couple questions we'll want answered before we're ready to sign off that the study is in good shape. By the time you see the study in places like EBSCOhost marked as peer-reviewed, that means it has passed these processes. The process is not foolproof, however, and occasionally weak studies or studies with issues do get published. When this occurs, critiques or responses to this work may be published. This is all part of the open system of scientific inquiry. This system not only requires us to use objective rules for gathering information and testing our own assumptions, but it encourages open sharing of information and ideas, and open response and critique of that information, and further study to find issues, errors, or to deal with gaps in existing research. Remember, it's never one study alone that tells us what is likely true of the world. It's all of the studies together with their benefits to help overcome the limitations across those studies that we use to build the knowledge of our field. Despite this, there are limits to scientific knowledge. Some questions cannot be answered succinctly or at all based on our current methods and measures. We have to always be open to developing new ways to test our ideas. Think, for instance, about the research that you've done in developmental psychology if you've taken that class. Researchers were interested in understanding the cognitive, memory, and math skills of infants and pre-verbal children. We can't simply give a pre-verbal child a math problem and ask her to explain to us how she solved it. In fact, we can't even ask them to tell us what the answer is. So what researchers have had to do is come up with new and ingenious methods. If you've taken a course in developmental psychology, you've probably seen the results of some of these more ingenious and creative studies. Researchers have used visual displays and watched how long pre-verbal children look at those displays as indicators of whether or not they notice changes in quantity. This gave us some indication of an underlying understanding of mathematical concepts in young children who couldn't report to us verbally what they knew or what they were thinking. Until we come up with a method or tool that allows us to fully assess a hypothesis, some of our questions just cannot be answered. You'll see some areas of the field that are really advancing in the development of new techniques. For instance, neuroscience has allowed us to see what's going on in the brain and which brain regions are active during various human tasks. This kind of study was not possible for us about 50 years ago. However, with the development of new techniques in neuroimaging, we've begun to amass information in this budding area of the field of psychology. Good theories are those that generate hypotheses. If you have a theory that does not lend itself to questions that are answerable through observation, this becomes problematic. A theory we cannot test doesn't really aid the field. Therefore, we're always asking, how can I test this? And if we don't have an answer to that, we must come up with novel methods to test the aspect of the theory that is currently untestable. Some hypotheses just have to wait decades or more for technology to catch up with them. With this, we have to note that all research studies are not created equally. You may have heard the phrase garbage in, garbage out. This means if you have a poor quality study, it doesn't matter how much data you collect or what those data indicate, the data should not be trusted. Results of poor quality studies can actually lead to erroneous conclusions. Therefore, we must know the various research methods and the situations for which they are best suited. Without knowing this and having a good understanding of the statistical techniques that are required, we are at risk of doing garbage research. Another concern is pseudoscience. This means fake science. Pseudoscience refers to any time conclusions are drawn that sound like they're based on good research, when in fact this is not the case. Just because you hear scientific sounding language doesn't necessarily mean that the proper or appropriate methods were used. In fact, the use of research phrases doesn't ensure that research was conducted at all. The scientific method, as we've noted, has specific steps that are required. If the steps were not followed, we may be getting into the realm of pseudoscience, regardless of how fancy the language sounds that's being used. We must also be on the lookout for special interests. As a behavioral scientist, the goal is to be objective. A reality of becoming a researcher is that sometimes you will refute your own hypotheses. We must learn to accept this. We will not always be right, and we want to put objective knowledge ahead of our own interests. In my own work as a researcher, I found that some of my hypotheses were not supported. When this has occurred, I've gone back to the theories, usually with my team, and the hypotheses, modified, clarified, and then began testing over again. So, as a researcher, there's nothing wrong with being incorrect, as long as we're transparent about it, or we don't put out something incorrect that we know isn't true, as though it were a fact. Let's focus on correlation for a minute and its limitations in drawing conclusions about causation. When we use correlational analyses, we're looking for whether or not two things are related. When I say X is correlated to Y, I'm saying there's a tendency for the two to co-occur or to occur in similar ways. If it's a positive correlation, that means high scores tend to occur with relatively high scores, and that low scores tend to occur with other low scores. If there's a negative correlation, it means high scores tend to occur with relatively low scores, or that low scores tend to occur with relatively high scores. This is a concept you should have learned about in statistics. What we must keep in mind is that correlation itself is not sufficient to determine a cause-effect relationship. Just because things tend to co-occur does not mean that either one of them is based off the other one. In fact, we must have several things at a minimum to help us deduce causation. First, we must consider something called temporal precedence. If one thing causes another, the cause must come before the effect. If they occur at the same time, or if the theoretical effect comes before the cause, a causal relationship cannot be determined as hypothesized. Temporal precedence, therefore, requires that the cause occur before the effect. Temporal precedence is not sufficient to determine causality, but it is a requirement before we can deduce causality. We must also see if there's covariation of cause and effect. The effect should occur when the cause is present and not when the cause is not present. If I see the effect absent the cause, this may be indicative that what I believe is the cause is not in fact the cause. Finally, at a minimum, I must consider and examine alternative explanations. This means I need to eliminate other things that might explain the effect in the hypothesized cause-effect relationship. I must consider other reasons I might see the co-occurrence. This requires that we consider confounding variables. A confounding variable, also known as an extraneous variable, isn't part of the hypothesized cause-effect relationship. Instead, the confounding variable may explain why the two other variables appear related or are related, and may indicate that neither one is the cause of the other. The word confound means essentially confuse, so a confounding variable is a variable that causes confusion in our understanding of the reality of cause and effect. Let's consider this with an example. Suppose there's a big exam about to happen. A tutoring session that lasts for 6 hours is offered and will review information that will be on the big exam. Let's also suppose that all students who attend the tutoring session are given a gold pencil while they are there, and they get to keep the gold pencil. Now suppose that at the exam, several students show up with the gold pencils and use them when they complete their exam. The rest of the students use an assortment of non-gold pencils. When examining the results of the big test, we might notice that students who completed the exam using a gold pencil did much better than those who had non-gold pencils. We might erroneously conclude that the cause of better test performance was the color of the pencil used. However, if we consider this just a little further, we'll realize that the gold pencil is the result of attending tutoring, and that tutoring is likely the real cause in the cause-effect relationship. This is an example of when a confound is present. If we don't think beyond our data, and our data are here only including pencil color and test performance, we'd be left with the erroneous conclusion that pencil color is what affected exam scores, when the true cause was the tutoring. For the majority of the semester, we'll be focusing on the details of different research methods. So today we'll start with a broad breakdown of basic versus applied research, and you'll see that terminology repeated when we get into the details of specific methods at various points in this semester. There are two main categories of research: basic research and applied research. Basic research produces foundational knowledge. This form of research generates facts and describes phenomena such as what behaviors look like and when they tend to occur. Think back to the goals of psychology from earlier in this video and see if you can decide which goals are best served by basic research. In contrast, applied research addresses issues and attempts to generate and test possible solutions. The goal of applied research is often to improve quality of life. Applied research is benefited by findings in basic research. Therefore, basic research often comes before applied research can be developed. A specific form of applied research is called program evaluation. Program evaluation assesses the implementation and effectiveness of various programs and interventions. This is often done in social, nonprofit, or public sector research. Program evaluation is just one example of a type of applied research. We've just completed a pretty detailed overview. After completing this video and the accompanying reading, you should be able to answer the following questions. What is the role of research in the field of psychology? And how is research applicable to your life and your career goals? What are the components of the scientific method as it is applied to the behavioral sciences? What conditions are necessary to determine a cause-effect relationship? There will be more that we'll learn about later in the semester, but here I'm asking you to reflect back to the ones that we've discussed today. What is basic research? Try to come up with at least 2 examples of research questions or findings that would fit into this category. What is applied research? Again, try to come up with at least 2 examples of research questions or findings that would fit into this category. Use these questions to assess your understanding of the video before moving on to any assignments or any new topics.